Okay, this is part 2 of the Tektronix oscilloscope that I was working on a while back. I built this dim bulb tester that's in the video that I uploaded previous to this one, specifically for this, and then also the old ICO 950B that I did a short piece on at the end of that video. This particular scope has no trace at all. The DMM part of it works just fine. There's nothing at all wrong with that section. So that kind of eliminates part of where the problem is. It doesn't lie in the battery charger board. It has to be after that, due to the fact that the DMM works just fine because it's powered off the battery charger board. But the next section in is the main power board that generates some of the voltages. It goes to the high voltage section and everything, and I've got an issue in there. And if I just plug this into the regular line voltage, or even use my Variac just specifically as nothing more than as a variable voltage source, and try to power it, say, to 60 volts, pretty much immediately get strong silicon smell, and usually after about a minute or so, a bit of a puff of smoke. So it's a little bit tough to take any voltage readings with this, and that's one of the reasons I built this dim bulb tester. Now, one of the nice things about this tester that you can do is you can vary your load. In the previous video, I had a 200 watt bulb that I had in there to run that ICO 950B. I've got a 60 watt bulb in this one. Started off with a 25 watt, and that was just too small. I could only get maybe 50 volts to the unit, and you could hear the switching supply oscillating, trying to start, and it just wouldn't do it. So I went to a 40 watt, same thing, a little bit better, but same thing. With the 60 watt, I still don't get the full 120 some volts. I get maybe 100 volts, and same thing, the oscillator for the switching supply keeps switching on and off, but it has done that all along. There's a problem here. I've got a high load somewhere. But this 60 watt bulb limits the power enough that even though after a fairly short time components overheat, I at least have the time that I can use this to kind of scope around and find out what component is heating up. And I'm going to plug this thing in, start it up, and demonstrate that right now. Cut that off. I don't know if you can see that or not. Okay, so flip this on. Okay, I think I've got this already on. Yep, it's already on. So start running this voltage up. I don't know if you can hear that oscillator trying to start up. Got that high pitched squeal. Now I'm using this to look around. I've got time to do that now. I know exactly what's heating up now, but I'm going across here some of the different components. And so far, not building a lot of heat, but now that particular transistor there is starting to heat up pretty fast. And I can actually start smelling. You notice, I don't know if you can see it or not, the bulb started lighting up. So as time went on, something is pulling more current here. But the power transformer heats up slightly, but I can see a little bit of smoke wafting up down in there. So there's something bad going on here. Not totally sure where. But got this transformer here, or this transistor here, and this one here both heat up considerably. And there's also something down in here that is as well. So I guess what I'll do, okay, I got this all off. Grab this thing. Trying not to hit any capacitors that are still charged up. Flip that thing on its side. And same thing, I can get down the bottom side now. Start checking heat. You can hear that thing trying to start, just back and forth, back and forth. But it's taking considerably longer for this thing to heat up to where you start getting smoke now. So I can kind of prowl around here for a minute or two, and then I start kind of smelling it and I shut it off, let it cool off. And you can kind of see the dim bulb as the thing runs. The dim bulb is lighting up slightly more, so something is happening here. But this gives me time to where I can actually kind of scope around here. It's really a pretty good test method if you think about it. It seems like there's two transistors in here, power transistors, that seem to be getting hot really fast. So I'll have to find the schematic, start searching around there, see what all's involved in that area. But you notice how instead of within literally 10 seconds I've got smoke coming out, this limits the current and limits the voltage to a point where I can scope around here for quite a while. So now, since my last video, I've also found a schematic and a little bit of a service manual for this. So this gives me time. I can take some voltage readings. I can hook a meter up and start actually troubleshooting this thing rather than flipping it on, smelling smoke and shutting it back off, trying to find out where the smoke's coming from. So I just thought the main reason I guess for this video is just to show you an application for this dim bulb tester that I built. This is limiting the current enough to where I can actually perform some testing rather than flip the thing on and almost immediately smell a strong semiconductor smell and a little wisp of smoke. It takes 2 or 3 minutes now, so I can do some voltage testing on this thing, and hopefully I can find out where the problem is. I'm half tempted just to leave it on and let whatever component it is burn, but because it's probably bad anyways, but that's really not the best way to troubleshoot something. I might end up with a fried circuit board, and I got a feeling that this is, like I said in the previous video on this, it's probably the high voltage section has the high voltage, not sure if it's a high voltage multiplier maybe, but I've got a feeling it is probably bad, and it seems like that is a common problem with these. So anyways, I just thought I would kind of demonstrate that application to you. You can limit the current and start probing around with a meter or with temperatures like I showed there. Now that I know I have two transistors that are getting super hot super fast, I can figure out what in that circuit there is and do some voltage readings in that area, and maybe I can come up with a solution to the problem. So anyways, that's about it for now.